I'm in my office. I'm Mason, and it's winter break. But last semester in 285, fall 2024, I noticed a problem that I wanted to go over, which is voltage division with nodal voltages. The first 3 weeks of circuits, we learned both node voltage division, which means if several resistors are in series, it doesn't need to be only one. The voltage drop across the resistors is directly proportional to the resistance. So I'm giving here a simple example. If somebody tells us there is a 10-volt drop between this node here and in this particular direction, so there are 10 volts here and there are 10 kilo ohms, that means it's really 10 volts divided by 10 kilo, that means it's really 1 volt per kilo ohm that you get. So really, if you add resistance divided by voltage, that's how much the voltage drop across the resistor is. So in this 4K there will be 4 volts, in this 6K there will be 6 volts, and how they add. This is how they add up: 4 plus 6. The catch is, with nodal voltages, we make ground somewhere in the circuit. So if I had asked you, if I put ground here, and I'm going to change color to show this, if I make ground this middle, and I ask you, what is Vx? What happens is, I am really switching these 4 volts. So you see how the arrow is here and the tail is here, so I'm asking, what is this voltage here? Hopefully you see that Vx is minus 4 volts, because it's the opposite direction of the 4 volts. If I had asked in black here, I put another ground, black, and now what is Vx? So the same Vx here, this would be minus 10 volts. Because again, I'm switching. So the 10 volts assumes that the ground is here, and I'm measuring on the arrow here. If I switch, then if the ground is on the right side, on this side, then minus 10 is on that side. Actually, the same thing can be drawn as a circuit like this. Maybe actually I drew it this way. So I'm gonna ask again sort of the same question. If my ground is here on this node, on the circuit B, if I put ground here, what happens is all the voltages that I ask, for example, V, Y, and VZ, are in relationship to this, and it turns out then VZ is minus 6 volts and VY is minus 10 volts. And yet, if I ask you, what is this voltage here, it's still 6 volts, and this voltage drop here is still 4 volts. I hope this is easy. So how these two are similar, or this is one circuit, this may be part of a circuit. So now I'm gonna show you, actually I'm gonna leave you with questions here, how to answer 4 different questions related to the same concept. So I drew 4 circuits that are the same so that I can put ground and ask you different questions. So this is the simplest. I'm assuming ground is here. What is VA, VB, VC, and what is this voltage here, VD? Well, I hope you know the VE is 0. And now I'm going to switch ground, and I'm going to put ground on this side, on the positive side. And I'm going to ask the same questions. V1, V2, V3, V4, and then also the same, what is V5 here? Finally, I'm going to ask, not finally, actually, I have 2 more. And then I'm going to put ground here. And then I'm going to put ground here between the 5 and the 7 pin. And then ask the same questions. Bx, B1, Bz, Bt. And still this one. Vu. And then Bf, Bg, Bh, Vi, and this one is Vj. So I hope with this simpler version of it, you can understand what voltage division with nodal voltages. And then with this is one step further. Instead, it's 3 resistors instead of 2. But I hope you can answer that, and please comment if it's too hard, and then I can possibly post another video showing how to solve this.